Today I will discuss properties of gas. This is part 1. First of all, what is perfect gas or ideal gas? The gases which strictly obeys gas laws. Okay, that means Boyle's law, Charles' law, Gay-Lussac law, Joule's law, Avogadro's law, Reynolds' law, under all condition of pressure and temperature. And there is no attraction between the molecules of the gases. And when its temperature reduces to 0, its volume becomes 0. And the gas which strictly obeys the perfect gas equation, that is PV equal to mRT, and there is no exist of any gases in the world. These are called perfect gases, or ideal gas. Now the gas laws are, first of all, Boyle's law. Boyle's law states that the pressure or absolute pressure is inversely varies to its volume when temperature equal to constant. That means you may be said PV equal to constant from this law. The second gas law, this is Charles' law. It states it states volume proportional to absolute temperature when pressure equal to constant. That means here you may be said V by T equal to constant. This is Charles' law. Third, Gay-Lussac law. It states pressure proportional to absolute temperature when volume is constant. That means here you may be said P by T equal to constant. Number 4, Joule's law. We know that the part of energy which is stored in the body and is used to raise its temperature, this is called internal energy, and the mathematical form of change in internal energy dU, that is equal to mCV dt, change in temperature. Now here mass is constant, specific heat at constant volume is constant. So du proportional to dt. That means change in internal energy is directly proportional to change in temperature. This is Joule's law. Number 5, Avogadro's law. Molecular weight, same molecular weight of all the perfect gases under pressure and temperature, same pressure and temperature, occupies the same volume. Okay, or you may be set in this form, equal volume of all the perfect gases occupies same molecule under same pressure and temperature. That means here molecular weight and volume, that is molecular volume, equal to constant. This is Avogadro's law. And number 6, Reynolds' law. Here it states that specific heat at constant pressure and specific heat at constant volume is always constant of any particular gas. These are gas laws. Number 1, Boyle's law, Charles' law, Gay-Lussac law, Joule's law, Avogadro's law, Reynolds' law. Okay, and the gases which strictly obeys this law are called perfect or ideal gases. Okay, now 3 equations from this law can be obtained. Number 1, general gas equation. This is PV by T equal to constant. Number 2, perfect gas equation, perfect or characteristic gas equation. This is PV equal to mRT. Here P pressure, V volume, M mass of the gas, R gas constant, and T absolute temperature. Yeah. Now, if mass of the gas can be converted in this form, this is number of mole into molecular weight. Okay, and this is RT. Now, molecular weight into gas constant, this is universal gas constant, R suffix U into T. That means PV equal to ANRUT. Yeah, when PV equal to mRT, this is perfect or characteristic gas equation. When it is converted into in this form, PV equal to ANRUT, this is called universal gas equation. Yeah, here RU universal gas constant and its value 8.314. This is kilojoule per kg mole per Kelvin. Yeah, 8.314 kilojoule per kg mole per Kelvin, and it is constant for all gases. Yeah. Okay, so number one, this is general gas equation, PV equal to mRT. Perfect gas equation, PV equal to ANRUT. This is universal gas equation. Yeah. Now, what is the difference between R and RU? That means gas constant and universal gas constant. Yeah. Look at the board. Suppose this is a quantity of gas. Yeah. Now, if you heat, Q quantity of heat is supplied to this gas at constant pressure. According to perfect gas equation, this is PV equal to mRT. Now, before heating, it can be said in this form, PV1 equal to mRT1, and after heating, it can be said PV2 equal to mRT2. Now, subtract P into V2 minus V1. This is mRT2 minus T1. Now, we know that P into V2 minus V1, this is external energy, the part of energy which is supplied to the body and is used for doing external work. This is called external energy, and this is W. Now, show W equal to mRT2 minus T1. Okay. Now, if M equal to 1 kg, T2 minus T1, this is 1 Kelvin. So, from this equation, it may be written W equal to R. That means, if 1 kg gas is heated at constant pressure, due to which temperature difference is 1 Kelvin, then the work done by the gas is gas constant, and this is the physical significance of gas constant. Yeah. Okay. W equal to R, this is the physical significance of gas constant, remember. Now, the difference between R and RU. Yeah. First of all, specific gas constant is denoted by R. Universal gas constant, this is denoted by RU. R equal to W, that means, remember, when 1 kg gas is heated at constant pressure, due to which temperature difference is 1 Kelvin, then the work done by the gas is called gas constant. And from perfect gas equation, we know that universal gas constant RU, that is equal to product of molecular weight into gas constant. Yeah. Now, gas constant, that is R, is different for different gases, but universal gas constant is constant, and its value we know that 8.314. Yeah, and its unit kilojoule per kg mole per Kelvin. But the unit of R, this is kilojoule per kg Kelvin, and this is the difference between gas constant and universal gas constant. Yeah. Now next, proof that change in internal energy del U equal to this is P2V2 minus P1V1 by gamma minus 1. Okay, proof. First of all, we know that Cp minus Cv equal to R. Specific heat at constant pressure, specific heat at constant volume. Difference, this is gas constant. Now, we know that, look, change in internal energy equal to mCv dt. Yeah. So, here this is Cv. So, divided both sides by Cv. So, Cp by Cv, that is equal to gamma. Cv by Cv, that is equal to 1, and here R by Cv. So, Cv equal to R by gamma minus 1. Okay. Now, putting the value of Cv in this equation, this is m into the value of Cv here, R by gamma minus 1, and dt means T2 minus T1. Okay. So, mR T2 minus mR T1 by gamma minus 1. And according to perfect gas equation, PV equal to mRT. So here mRT2 means P2V2, mRT1 means P1V1 by gamma minus 1. So here del U equal to this. Yeah, and it is proved. Change in internal energy equal to P2V2 minus P1V1 by gamma minus 1. Yeah. Next proof. Heat supplied Q equal to gamma into P2V2 minus P1V1 by gamma minus 1. Yeah. Similarly, as before, we know that Cp minus Cv equal to R. Yeah. Here, we know that Q equal to heat supply equal to mCp T2 minus T1. So here Cp. So here divided both sides by Cp. So Cp by Cv, that is equal to 1. Cv by Cp, that is equal to 1 by gamma. Cp by Cv equal to gamma. So Cv by Cp, that is equal to 1 by gamma, and here R by Cp. So taking LCM, this is gamma, here gamma minus 1, R by Cp. So the value of Cp, that is equal to gamma R by gamma minus 1. Now, putting the value of Cp in this equation, okay, m into gamma R, gamma minus 1, the value of Cp, and here T2 minus T1. So, gamma common, this is mR T2 minus mR T1 by gamma minus 1. And according to perfect gas equation, mRT2, that means P2V2, mRT1, that means P1V1 by gamma minus 1. So Q equal to this. This is proof. Yeah. Now, next proof, this is Cp minus Cv equal to R. Take your concentration on the board. Prove that Cp minus Cv equal to R. Yeah. First of all, consider as before what is the physical significance of gas constant R. Yeah. Look, here some quantity of gas and it is heated at constant pressure. Okay. Before heating, that is PV1, as pressure is constant, PV1 equal to mRT1. This is before heating. After heating, this is PV2 equal to mRT2. Now subtract. This is P into V2 minus V1. Here mRT2 minus T1. And we know that P into change in volume, pressure into change in volume, this is external work done, external energy W. So here W equal to mR T2 minus T1. Yeah. Okay. Now, according to law of conservation of energy, we know that heat supplied Q equal to W plus del U. Yeah. Now, Q equal to, as heat is supplied at constant pressure, so Q equal to mCp T2 minus T1, and here W from equation 1, this is mR T2 minus T1, and change in internal energy, its value mCv T2 minus T1. Okay. Now dividing both sides by T2 minus T1, am into T2 minus T1. So here am into T2 minus T1, if you divide, then it is Cp am into T2 minus T1. This is R, and here this is Cv. Okay. So Cp minus Cv, that is equal to R, and here it is proved. Okay. And from this equation you may be said, we know that in universal gas constant Ru, that is equal to m into R. So here R equal to m by Ru. So from this equation, here the value of R, this is m by Ru. So Cp minus Cv equal to R, or m by Ru. Yeah. Sorry, Ru by m. Here it is Ru by m. Okay. It can be also proved. This is Ru by m. Yeah. Now the next question, what is the value of heat supply, internal energy, work done, change in enthalpy, change in entropy, okay, for constant volume process, constant pressure process, constant temperature process, adiabatic process, and reversible adiabatic process, and polytropic process. Yeah. And this will be discussed on the next part of gas. Okay. Thank you.